Now this video is about equation of a line. We say parametric equation of a line. We're going to find the equation of a line passing by P0 parallel to a vector V. Since this line L and vector V are parallel, we can say let P be any point here. Components of P, X, Y, Z belong to the plane, where P0 the components are known, X naught, Y naught, Z naught. So here if you want to find the component of P0, P, so x minus x naught, y minus y naught, z minus z naught. Since they are parallel to vector v, we know in that condition x minus x0 over v1 equal y minus y0 over v2 equal z minus 0 over v3 equal t. So if you do each one, so here x will be v1t plus x0, y will be v2t plus y0, here y0, and z equal v3t plus z0. So the parametric equation of a line is x equal x0 plus tv1, y0 plus tv2, z equals z0 plus tv3, where t belongs to R, and v1, v2, v3 are the components of any vector parallel to the line, and x0, y0, z0 are the components of a point belonging to the line. So let us take an example to understand it. For example, here the equation, find the parametric equation of a line passing by the point A and parallel to V. Because parallel to V, we start by V minus 2t, 3t, 1t, as you can see, and passing by point A, we say plus 1 minus 2 plus 3. So this is the parametric equation of a line. And for any value of t, you're going to get points, and these points, if you connect it here, for t is 0, t is 0.1, t is radical 3, t is minus 2. This set of points will be a parametric, the line that you have. Here, find the parametric equation of a line passing by 2 points A and B. Since passing by 2 points A and B, so this line is parallel to vector AB. So now I need a direction. So it has the same direction as vector AB. So these are the components of vector AB by doing xb minus xa, yb minus ya, zb minus za. So you're going to get t minus t and minus t minus t minus t. Passing, for example, either you can pick point A or point B. If you pick point A, you put here minus 1, here plus 2, plus 3. If you pick point B, you put plus 0, here 1, and here 2. Number 3, find the equation of a line passing by the midpoint of AB and parallel to that line. Since parallel to that line, so it has the same directing vector. So directing vector here, the coefficient of t, 1 minus 1 minus 1. So 1 minus 1 minus 1. And passing by the midpoint. The midpoint of AB will be, if you add the boundaries over 2, the components over 2, you have the point M. So you put minus 1 plus 4 minus 1 and t prime instead of t. You need to change it, because if you put t and t, it means they have the same parameter. So put it t prime. The distance from point S to a line through point, suppose I want to find the distance, before we have the distance from a point to a plane, we said a distance from a point to a plane. So we said the distance from a point A whose component x naught, y naught, z naught to a plane P is a x naught plus b, y naught plus c, z naught plus r over radical a squared plus b squared plus c squared, where the normal of the vector has components a, b, and c. Suppose I want to find the distance from a point to a line L, and this line L is parallel to vector v. So what do we do? You can check it. This is the property of it. You can this is the proof. So directly, I know what I want. The distance is nothing else. You pick any point on the line, any point P on the line. For example, if you want to pick here any point, you can take t0. So you have the point 1, 3, 0. You can pick t1. You're going to get 2, 2, and t is 1, 2, 2, 2, 2. So you pick any point. You do what? The norm of PS cross the normal of the directing vector of V. Okay, over norm of V. So let us take this example. Find the distance from point S to line L. So you pick any point on that line. So you can take t is 0, the easiest. You're going to get 0.130. So this is nothing else than PS. Okay, PS. What are the components of PS? 1 minus 1 is 0. 1 minus 3 is minus 2. 5 minus 0, 5. And the directing vector of the vector are the coefficient of t. So 1 minus 1, 2. So you do PS cross V. So ijk, this is the ps, this is the v. So it will be cancel row and column. You're going to get minus 4 plus 5, 1. For j, you're going to get minus 5, and you have minus j, so it will be 5. For k, it will be plus 2. So you're going to have absolute value of this one. So it will be 1 square root 1 plus 25 plus 4 over norm of v. The norm of v here, it will be root 1 plus root 1 plus 4. So this is the answer. So this is the formula. You need to memorize it. Okay.